Okay, this is Mr. Peterson, and we're finishing up page 3 of 3, in other words, the last page of the 2.7b notes for Honors Algebra 2. And what we're doing on example 4 here is we're trying to find where this parabola and this line cross each other. And in this case, we have a point of tangency, which means we're only going to get one answer here. Now, to see that on your graphing calculator, you want to solve for y. And then I've got this pre-programmed in here. You can see I've got those equations typed in already. And I'm going to hit zoom 6 on this to see the picture, and you'll see the parabola and the line actually just gives it a glancing blow as it goes by. So somewhere down in this area here is the answer we're looking for, the point of intersection. And the point is, you're going to find this thing algebraically, so you have to come over here and do all the work to show those answers. So let me explain the work. I first copied the quadratic equation, the one with the x squared, and I solve for y. And I take that expression, and I'm going to plug it in for the y value in the linear one, so you can see this y is going to be replaced with that red stuff. Put it in standard form, and now you want to see if this is going to factor. So I'm going to show you two ways to tell if you can use a star to factor it. One is just to look at the a and the c and multiply, just in your head say those multiply to give 4, which will end up right there on the star. And the middle number goes underneath it. If you can think of two numbers that multiply to give 4 and add to give negative 4, if you can think of that before you get the star written, you won't waste any time trying this. The other way is to go to your home screen and type in the b squared minus 4ac part of the quadratic equation. It's called the discriminant. So b squared would be 16, and then there's always a minus 4 in the formula. This is the quadratic formula that we did earlier, times the a and the c. And if you get a perfect square, like 0 is a perfect square, that's 0 times 0, or 36 or 25 or some other perfect square, then you can factor it and the star will work. So at any rate, negative 2 times negative 2 are the magic numbers. You see that multiplies to give 4 and ends to give negative 4. So we come over here with the factored version, x minus 2 and x minus 2. Both of those yield just one answer, 2. So you put that in for x, and then you stick that value into the linear equation. You can actually use either one, and you can calculate the y value quickly. So what I sometimes do here, you'll see me do this on another problem. I'm going to take 2 and store it as x, and then I just type 2x minus 5 and let it plug that value in for me. So there it is, negative 1. Now let's go back to our graph, and we're going to see if that's the right answer. You go second, calculate, choice number 5. Move your cursor till it's basically on top of the answer and hit enter 3 times. And you should get 2, negative 1. Now you can see the calculator's having a little bit of issues getting an accurate answer here, but that's basically for all intensive purposes 2, negative 1. And the calculator is actually having rounding errors when it goes from decimal numbers on the screen, which we type and understand, to the internal ones and zeros, which is base 2, and then back to base 10, where we understand numbers on the screen, and that's where these tiny trace errors come in. Like here, it's well, that's 1/1,000,000th off. Okay, so we've got the right answer there. All right, so the problem at the bottom of the page, what you're going to have is a parabola that the line misses the parabola, and so there's no real number solutions is what we're going to get here. But to show that, you got to take it all the way down to where you've got I as part of the answer for x, and those aren't real numbers, those are complex numbers. So let me show you how this works here. First of all, you're going to take the y value on the quadratic line, in other words, negative x squared plus 2x plus 4. You're going to plug it in for the y. You can see me doing that right there. Simplify, I distributed and brought the 19 back. Simplify again by collecting like terms. And we have a luxury when there's an equal sign. We can divide by anything we want, so I'm going to divide by -1 to change my signs. 0 divided by -1 is just 0. And all of these, when you divide them by -1, it changes the signs. And I'll plug this into the quadratic formula. Work it all the way through. You can see I split the -20 up as to 4 and 5. And it comes out. And the last step here is to divide in a triad. Divide by 2, divide by 2, and divide by 2, and you get your answer here. Now when you see this I as part of your X answers, you know that you're not going to find those on this grid. In other words, in this case, you're not going to find intersection points. So that's why you write no real solution, even though there are solutions. They're imaginary or complex here. Okay, so I have one last thing to do, even though you're at the end of page 3. And that's to warn you, and you can use the back side of your notes. There's a blank page there to do another example here, but we're only going to shortcut straight to the answers here. I want to show you how to use your calculator to get the right points of intersection. So what I've done here is I've solved this one, and I get down to an irrational result with a square root of 7, which really makes nasty numbers. So let me show you how to handle it from this point on. When you get the square root doesn't just disappear like on most of the problems you have for homework. You're going to go to your home screen and you're going to store the first version, -2, you need parentheses, -2 plus root 7 divided by 3 in this case is the answer. You want to store that as a value of X. Now, it's going to show all the accuracy out here, but when you write it on paper, and only when you write it on paper at the last minute, you can round. So it's 0.22 if you're rounding to the nearest hundredth. But you stored the full accuracy, and that's the proper way to do it. So now when you go to the y, it says the y is equal to 4 times that x minus 5. So all I have to do here is go 4x minus 5, and I'll get this other number here. So then to get the other one, I'll use the minus sign. So you can watch me do it here. I'm going to go up and grab that one so I can edit the plus to minus. And that'll give me this answer. It's also stored. You can see that the stored for x. It's already also there. So when I type this, it's going to use that new x value. And you get this second answer right here. Now don't round in the middle of your problem. In other words, use the full accuracy of the calculator until you're finally ready to write the answers on paper. So we did that with the x, and later we plugged in the full accuracy of the x by storing it to get the y. If you round in the middle of your process, the rounding can become significant depending on what happens to that number later in the calculations. So the rule in math is don't round until the end, the final result. Okay, so that does it for page 3 and that one extra example on the back, example 5.